I am Dr. P. Ushamani, Professor EEE SNH Department, RMD Engineering College. I am going to brief about the conduction current density in intrinsic semiconductor. Basically, the charge densities in a semiconductor, if you consider, if a pure semiconductor is doped with n-type impurities, means the number of electrons in the conduction band increases above a level and the number of holes in the valence band decreases below a level. This would be available in the intrinsic semiconductor, that is pure semiconductor. Similar to this, we can say for p-type impurities, if you add, that means the addition of p-type impurities to a pure, that is intrinsic semiconductor, this will increase the number of holes in the valence band above a level and decreases the number of electrons in the conduction band below a level, which would be available in the pure semiconductor. Okay. So based on this, we are going for finding conduction current density. Conduction current density formula J is equal to conductivity into electric field. This sigma conductivity we can say, which is reciprocal of your resistivity. Okay, if in the given question resistivity value is given, you can find a sigma as using this formula, which is reciprocal of resistivity, and we can based on mass action law. What is this law? As under thermal equilibrium, for any semiconductor, the product of number of holes P, number of electrons N is constant, which is independent of the amount of donor and acceptor impurity doping. So based on this formula, Np is equal to N suffix I the square, where already I have mentioned the law. Under thermal equilibrium point, the product is constant. So N is number of free electrons, P is number of holes, and Ni is intrinsic concentration. Okay. So based on this, we are going to find out J as current density. So your conductivity equation as Q into N mu N plus P into mu P. That is a donor and acceptor of the N-type and P-type, the impurities we are taken care. So in this P equation as Ni square divided by Nd, where Nd as donor density, we are considering N. So based on mass action law, P we are taken as Ni square by N. So that equation only this. Then if you know your P, we can substitute here. So from this equation, what is your, you can write this equation, sigma I is equal to Q into Ni. Within bracket, you can write a mu N plus mu P. Okay. So from this equation, I can find my Ni. Ni as the intrinsic concentration. So which is sigma I divided by Q into mu N plus mu P. So if I calculate this, I can calculate my J current density. So based on this formulas, we can solve one problem. We are considering a sample of silicon at a given temperature T in intrinsic condition has a resistivity as given in the question 25 into 10 power 4 ohm centimeter. The sample is now doped to the extent of 4 into 10 power 10 donor atoms per centimeter cube and 10 power 10 acceptor atoms per centimeter cube. Find the total conduction density if an electric field of 4 volt per centimeter is applied across the sample. Given the values, mu N is equal to 1250 centimeter square per volt second, mu P as 475 centimeter square per volt second at the given temperature. So based on the formulas what we have referred till now, we are going to apply for the given data. So now considering this data, first I am calculating the conductivity. Conductivity equation as sigma into E electric field. Sigma as current density J, which is equal to conductivity into your electric field. So now sigma I you are going to find out using the formula, which is Q into Ni into mu n plus mu p. The given value of sigma I they have given in the question, which is equal to resistivity as given in the question. So the relationship as both are reciprocal, conductivity and resistivity. So I am substituting 1 by resistivity. So 1 by 25 into 10 power 4 given data. So from this equation I am taking Ni equation, Ni as sigma I divided by Q into mu n plus mu p. These two are given values, and we are considering Q as electric charge value 1.602 into 10 power minus 19, and then we are substituting the given values of mu n and mu p. Okay, so if you substitute these values after simplification, my answer is Ni as 1.45 into 10 power 10 centimeter minus cube. Now net donor density Nd, which is N we have assumed, which is equal to donor atoms minus the acceptor atoms. So this is the given data in the question. So we have taken that difference between these two, donor and acceptor atoms. So the difference is 3 into 10 power 10 centimeter for minus 3. Now I am going to find out P, which is equal to Ni square divided by Nd or N. So I have substituted the values of N as Ni as 1.45 into 10 power 10 the whole square divided by N value or Nd value as 3 into 10 power 10. After simplification, my answer as P as 0.7 into 10 power 10 centimeter power minus 3. Next step I am going to use in this sigma, which is equal to Q into N mu n plus P into mu P. Now I know both the values of N and P. I have substituted the values of N and P, and applying the given data of mu n and mu P. After simplification, my answer for sigma is 6.532 into 10 power minus 6. Okay, the unit is Siemens per centimeter. The total conduction current density formula is J, which is equal to sigma into E electric field given in the question. So I am substituting the electric field given in the question as 4 volt. So I am multiplying that by sigma. Sigma is calculated now. So if we do the simplification, the total current density, conduction current density as 26 microamps per centimeter square, 26.128 into 10 power minus 6 amps per centimeter square. So based on the formulas of using mass action law, we can calculating total conduction current density in the intrinsic semiconductor. Thank you.